Dear students, today we are going to discuss about an important topic of Boolean algebra. In our previous class, in our previous session, we have discussed about the principle of duality. After principle of duality, now we are going to discuss an important topic of Boolean algebra, that is basic theorems of Boolean algebra. Here, in this topic, we are going to discuss about some basic theorems of Boolean algebra. As in other subjects, and also there are some theorems like that. The same way, Boolean algebra also includes some theorems. Now we are going to discuss the theorems, basic theorems of Boolean algebra, one by one in detail. I need your complete concentration here. If you understand the basic theorems of Boolean algebra, then after this, the next topics will become easy for your understanding purpose. So hope you are giving the complete concentration here. Now we shall discuss what is actually means the basic theorems of Boolean algebra. Look here, basic postulates of Boolean algebra. Basic postulates of Boolean algebra are used to define the basic theorems of Boolean algebra. The basic theorems of Boolean algebra. What are the basic postulates of Boolean algebra? In our previous class, we have discussed if x is not equal to 1, then x is if x is not equal to 1, then x is equal to 0. And then if x is not equal to 0, then x will be equal to 1. After that, logical addition, that is OR relation. Then after that, AND relation, that is logical multiplication. Then after that, the last one is the complementation. These are the four basic postulates of Boolean algebra. So those basic postulates of Boolean algebra are used to define the basic theorems of Boolean algebra, and that provide all the tools necessary for the manipulation of Boolean expressions, for the manipulation of Boolean expressions. Okay, basic postulates of Boolean algebra are used to define the basic theorems of Boolean algebra. Okay, and that provide all the tools necessary for the manipulation of Boolean expression. Okay, these basic theorems will provide all the tools necessary for the manipulation of Boolean expressions. After that, although it is simple in appearance, it looks simple. Okay, these theorems will look very simple and very easy. Okay, these theorems are used to construct Boolean algebra expressions. Boolean algebra expressions. Hope you are understanding here. Okay. In our last class, we have discussed about the basic postulates of Boolean algebra. Okay. All those postulates, basic postulates of Boolean algebra are used to define the basic theorems of Boolean algebra. Okay. Then these theorems provide all the tools necessary for the manipulation of Boolean expressions. After that, although it is simple in appearance, it means these theorems, okay, basic theorems are very simple. If even though they are simple in appearance, okay, if they are even though they are simple in appearance, what are the use of these theorems? These theorems are used to construct Boolean algebra expressions. Okay, these Boolean basic theorems of Boolean algebra are used to construct the Boolean algebra expressions. Hope this one you have understood. The next thing here is the next thing here is basic theorems are proved. Okay, we are going to prove these basic theorems now. So, basic theorems are proved by by substituting substituting all the possible values of the variables. Okay, how we can prove these basic theorems? They can be proved okay, by substituting all the possible values of the variables. What are those possible values? That is 0 and 1. Okay, by using 0 and 1, we will prove the basic theorems by substituting these two values. Okay, and the technique of okay proving these theorems is called okay proof by perfect induction. Proof by perfect induction. Okay, with the help of zeros and ones, we will going to prove the basic theorems by substituting all the possible values. How many possible values are there? We will going to use these values to prove the basic theorems, and also the technique which is used to prove the basic theorems. That technique will be called as proof by perfect induction. And also these basic theorems are also proved by the truth table. Okay, two things are there. One, by substituting all the possible values, we will prove basic theorems. The second thing here is with the help of truth table, we are going to prove these basic theorems, and the technique which is used to prove the basic theorems is called as proof by perfect induction. Okay, you will get a question in your examination as what is proof by perfect induction. Then you have to write okay, if you get a question what is proof by perfect induction, then you have to write proof by perfect induction. Proof by perfect induction is a method of okay, proof by perfect induction is a method of proving basic theorems of Boolean algebra by substituting all the possible values of the variables. Okay, proof by perfect induction means, okay, it is a method of proving basic theorems, okay, of Boolean algebra. Okay, it is a method of proving basic theorems of Boolean algebra by substituting all the possible values of the variables. By substituting all the all the possible values of the variables. So, with the help of proof by perfect induction, now we are going to prove the basic theorems of Boolean algebra. Okay, now we are going to prove the theorems one by one. Now look here. Here, basically there are four things. First one is 0 or x, which is equal to x. Okay, you know that. Okay, anything is odd with 0, then you will get the same thing. Okay, 0 plus 1, it will become 1. Here 0 plus x is there, so it will get x. Okay, here 0, then x, then the odd relation. Okay, it will become x. Okay, this is the first one. Next, second one, 0 plus 1, okay, which is equal to 1. Sorry, x plus 1, which is equal to x, or 1 plus x, we can take like this. 1 plus x is equal to x. Here we are writing like this. Okay, 1, then x, then answer will be x. Okay, 1 plus x is always x. Next, this is for OR relation. For OR relation, two things. 0 plus x is equal to x, then 1 plus x is also equal to x. It will not become 2. Okay, remember this. Next, 0 into x, which is equal to 0. 0 into x, which is equal to 0. I will write AND gate for this. See, 0 into x, which is equal to 0. The next thing is 1 into x, which is equal to x. Okay, one, two things here. One into x, which is equal to x. Okay, zero into x is equal to 0. Then 1 into x is equal to x. Now we have to prove these two things basically. Okay. Now we are going to prove these four things one by one. First one is 0 plus x which is equal to x. Now we have to prove these things by all the possible values. The first thing here is, okay, take if x is equal to 0, okay, we have to prove if x is equal to 0, then LHS equal to, okay, 0 plus x. We have to take this expression first. We are using x is equal to 0 here. Okay, as we have known, we will prove these theorems by substituting all the possible values of the variables. The possible values are 2, 0 and 1. First we will take x equal to 0, then LHS, left hand side, and this is right hand side. LHS we will take 0 plus x. 0 plus x which is equal to 0 plus which is equal to 0 plus x. X means what is the value of x is here? 0 plus x. So the value of x here is 0, which is equal to 0, and here 0 is there. So this 0 is equal to x. X is equal to 0 and 0 is equal to x. Okay, then the answer will become x. This is RHS. One thing is RHS. Okay, listen one more time. If x is equal to 0, we are taking first value x is equal to 0. Take the left hand side. This is left hand side and this is right hand side. LHS and RHS. We will take LHS, right, left hand side. That is 0 plus x. 0 plus x. We will take 0 as it is, plus as it is. But the value of x we have taken here is 0. The value of x is 0 we have taken. So we will put the value as 0. So 0 plus 0 is, answer will be 0. If answer is 0, then that 0 is equal to x. Okay, if answer is 0, then that 0 is equal to x. So here the answer will become x. This is first. Next, if x is equal to 1, if x is equal to 1, take left hand side. LHS is equal to 0 plus x. LHS is equal to 0 plus x. Okay, sorry, 0 plus x. Then which is equal to 0 plus. Okay, what is the x value here? X value is 1. So we'll take x value as 1. Okay, x value is 1, we will take 1. 0 plus 1. Okay, if we are or if we add 0 with 1, then the answer will become 1. So here the x value is 1. So 1 will become as x, which is equal to x. RHS. RHS. Now we will going to write a truth table for this. Okay, we're going to write a truth table for this thing. We have taken this one. Okay, 0 plus x which is equal to x. So here this is two variable, one is 0, another one is x. So values will be like this, 0, 0. Okay, because 0 is here, we will take 0. X value is, one is 0, another one is 1. Okay, then 0 plus x. 0 plus x. Look here. Okay, possible values for 0 and x. If 0 is there, then values are always 0. Okay, then for the variable x, we have taken two values, one is 0, another one is 1. If we do 0 plus 0, which is equal to 0, 0 plus 1, which is equal to 1. This is the truth table for this thing. So, as x can have the values 0 and 1, okay, when both the values when both the values are odd. Okay, what is meant by odd here? Odding means doing addition. Okay, then the value, then the result will be that of x. Okay, we have proved first thing. Okay, for if x is equal to 0, we have proved which is equal to x. Then for second value, if x is equal to 1, we have proved it for x. So for all these things, if x can have 0 and 1, when both the values are odd, 0 and 1 are odd, they are added, then the result will be that of x. Then the result is always x. Hope you have understood this. Then come to the second one. One plus x which is equal to x. 1 plus x which is equal to x. Take this as LHS and this one as RHS. One is LHS, another one is RHS. So if x is equal to 0, first we will take x as 0, then LHS is equal to 1 plus x. LHS is equal to 1 plus x, which is equal to 1 plus, okay, what's the value of x here? The value of x is 0. We will take this as 0. Okay, we will take this as 0. Okay, which is equal to 1 plus 0 is equal to 1. 1 plus 0, which is equal to 1. Then this is called as RHS. Okay, 1 plus x, which is always equal to 1 here, not x. 1 plus x, which is equal to always 1, because 1 plus 0 is here. Okay, we have taken the value as, first one is 0 plus x, which is equal to x. The next one is 1 plus x, which is equal to 1. Okay, like this. 1 plus x is equal to 1. LHS and RHS. We will take LHS 1 plus x. If x is equal to 0, then the value of x is 0. Then 1 plus 0 is equal to 1. This is RHS by OR relation. By OR relation. The next thing is, if x is equal to 1. If x is equal to 1, then LHS is equal to, see, LHS is there, 1 plus x. 1 plus x, which is equal to 1 plus, the value of x is 1 here. Okay, in OR gate, we have to do the OR operation. 1 plus 1 is, which is equal to always 1, that is equal to RHS by OR relation. Okay, now we are going to write a truth table for this. 1 here, then x is here, then r equals 1 plus x. See, for first column, variable is 1, so we will take both the values as 1 here. Okay, then for x, first one is 0, because we have taken 0 here. The next one is 1. Okay, remember these two. Okay, x is 0, x is 1. Okay, we have to OR. 1 plus 0 is equal to 1, right? then 1 plus 1 is also equal to 1. 1 plus 0 is equal to 1, then 1 plus 1 is also equal to 1. And same as x can have the values 0 and 1. Okay, when or means we will do addition here, oring. When odd, okay, the result will be 1. That is 1 plus x is equal to 1, which 1 plus x is equal to 1. It is tautology. This is tautology, because why? We have discussed that if any result of an expression is always 1, then that expression is called as tautology. See here, x is having the values 0 and 1. When they are odd, okay, then the result will be 1. So 1 plus x which is equal to 1, therefore it is a tautology. In other words, you can write here in odd with 1. I'll write here clearly for your understanding purpose. As x can have values 0 and 1, and when these values are odd with 1, okay, these values are odd with 1, then the result will be 1. That is 1 plus x which is equal to 1, therefore it is tautology. Because if any result of an expression is always 1, that expression we can call it as tautology. So here 1 plus x, we have got the result 2 times 1 for the value of 0. We have taken if x is equal to 0, then also we have got the value as 1. Then if x is equal to 1, then proved 1. Okay, so for all these things here we have got the result as 1. So it is called as tautology. This is about the first expression. Okay, now we are going to derive the next expression or the next theorem. Okay, two things we have proved, two theorems. First one is 0 plus x is equal to 0. This is the first theorem. Then second theorem is 1 plus x which is equal to 1. Then the third one is 0 into x which is equal to 0. Now we have to prove this. 0 into x which is equal to 0. So here this is the LHS part and this is the RHS part. Okay, first we will take it for 0. If x is equal to 0, we are taking x value as 0 here. Now prove LHS is equal to, we are taking left hand side, 0 into x. 0 into x which is equal to 0 into the value of x is 0. 0 into the value of x is 0 here. So then 0 into 0 which is always be 0. This is RHS. This is RHS. Then now we are taking if x is equal to 1. X is equal to 1. Then take the same LHS left hand side, that is 0 into x. Okay, which is equal to 0 into the value of x is 1 here. So 1. Okay, which is equal to anything into 0. We have know that anything into 0 is always 0. Therefore, this is RHS by and relation. By and relation. Hope you have understood. 0 into x is always 0. See, x is equal to 0. LHS. Left hand side we have taken 0 into x. So 0 we take as it is into as it is. Then x, the value of x is 0 here. I have put 0 here. Then 0 into 0 is 0. This is RHS, right hand side. Then left hand side. If x equal to 1, take left hand side, that is 0 into x. 0 into x. Take 0 as it is, then value of x is 1 here. Okay, 0 into 1. That is, you know that 0 into anything is always 0. Here 0, that is RHS by and relation. Now we are going to write a truth table for this. For 0 variable, x variable, then r is equal to 0 into x. So 0 here, for this we are taking 0. Okay, then for x 0 and 1, because we have taken 2, x is equal to 0, then x is equal to 1. So 0 and 1. Then we are doing AND operation here. AND means logical multiplication. 0 into 0 is always 0, then 0 into 1 is always 0. 0 into anything will always be 0. Hope this thing you have understood. And now, when or as x can have values 0 and 1. Okay, x can have values 0 and 1 when ANDed means logical addition, when ANDed with 0. Okay, if 0 and 1 when ANDed with 0, then the result will be then the result will be 0. Then the result will be 0. That is 0 into x is equal to 0. It is fallacy. It is fallacy. What is fallacy? If the result of any expression is always 0, then that expression we can call it as fallacy. Here we have got result of an x is always 0. See, result of an x first time is 0, then second time is also 0. So this, for this reason, we call 0 into x is equal to 0 as fallacy, because for every operation we have got the result only 0, as according to the definition of the fallacy. Okay, if result of any expression is always 0, then that is called as fallacy. So for that reason, 0 into x we have got the result only as 0, so this is called as fallacy. This is about the third theorem. And the last one is 1 into x, which is equal to x. 1 into x, which is equal to x. First we will take, see here, this one is left hand side and this one is right hand side. Okay, first we will take if x is equal to 0. X is equal to 0 here. Say LHS, which is equal to, okay, 1 into x. Okay, this is equal to 1 into the value of x is 0. The value of x is 0. No, here this will become Look here. If x is equal to 0, 1 into x is equal to 0. 1 into the value of x is 0 here, which is equal to, okay, which is equal to 1 into 0 is 0. So the value of 0 is x here. The value of 0 is x here. So we will take this as x RHS. Okay, I will explain once again. 1 into x 1 into x is equal to x. 1 into x is equal to x. LHS, this one is RHS. If x is equal to 0, take the first value as 0. LHS is equal to 1 into x. 1 into x. 1. Then the value of x is 0 here. So 1 into 0, it will become answer is 0. When 0 is here, okay, when 0 is here, so 0 is equal to x. So the answer is x here. Then if x is equal to 1, if x is equal to 1, LHS is equal to, look here, LHS is 1 into x. 1 into x, which is equal to 1 into, the value of x is 1 here. So this is equal to 1 into 1 will become 1. So 1, okay, 1 into 1 is 1 here. So here 1 is equal to x. So the answer here is x. RHS by and relation. Okay. For your understanding purpose, I will explain you one more time. 1 into x is equal to x, because if x is equal to 0, we will take initially x is equal to 0. Here two parts are there, one is LHS, another one is RHS. LHS is equal to 1 into x, we will take left hand side of the expression. Then take 1 as it is into x value is 0 here, so put 0 for x. Okay, then 1 into 0 is 0. And here 0 is equal to x. If x is equal to 0, then 0 will be equal to x. Then the answer is x. This is right hand side. And takes the value as 1. If x is equal to 1, then take LHS, left hand side. 1 into x. Take 1 as it is here. The value of x is 1 here. So take the value of x as 1. Then for ANDing, 1 into 1, answer will be 1. When and if when 1 is here, so then 1 will be equal to x. So put x here, the answer is x. So take, write the truth table for these two things. 1 x, there are equal to 1 into x. R is equal to 1 into x. 1 is there, so take two values are 1. And x value, 1 is 0, another value is 1. Take 0 and 1. Then the truth table will be like this here. Here it is 0 and here it is 1. This is the truth table for this theorem, this operation. Then now we can write as x can have the values, x can have the values 0 and 1, okay, when ANDed with 1, then the result will be x. Then the result will be x. If x can have the values 0 and 1, when these things are ANDed with 1, then the result is always x. Okay, so we have proved 4 things, and these 4 things are called as, now what we have proved, these 4 things are called as properties of 0 and 1. Properties of 0 and 1. There are 4 things. First one is 1 plus x, which is equal to x. Okay. Then the second thing is, sorry, First one is 0 plus x. First one is 0 plus x, which is equal to x. Second one is 1 plus x, which is equal to 1. 1 plus x is equal to 1. I have written already and I am repeating the same thing here. See, 0, then x, then the answer will be x here. Okay, then for this, okay, 1 plus x, then the answer will always be 1. Then C, 0 into x is equal to 0. 0 into x is equal to 0. I will write and wait for this. Here 0, here x, then the result will be always be 0. Then D, 1 into x, which is equal to x. 1 into x, which is equal to x. Now I will write and wait for this. One into x, it will become x here. 1 into x, then the answer will be x. See here, for every expression, then the result is 1. So this is called as tautology. And for every expression, here the result is 0. So it is called as fallacy. Hope you have understood the basic theorems of Boolean algebra. If you have any confusion regarding these things, you can ask me personally, and thank you.